today's presentation is really about how do you handle step files? Just some techniques. They've been around for a long time. People have been using them a lot. But this year, even though we're in April, I get a lot of phone calls, a lot of support requests in regards to STEP, and just how do they manage them. So I just want to talk about a couple of workflows. Some of them may be new to you, some of them may not be. I'd love any kind of interaction, feedback. If you have any tips and tricks of your own, let me know. But I'm just going to start off with this. And what I'm going to do is, because I have to look away from the camera, I'm going to shut my camera off, and I'll come back on in a minute. So, Anna, can everyone see my my Inventor screen?
No yet. I think maybe you can stop sharing and then sharing it again.
Okay. Let's see. Share. There we go.
Yes, now we can see it.
All right, thank you. So what I did was, when I was a machine designer, I would download a lot of step files to interact with my assemblies. And this is an example of one of those. I'm just going to open up a step file. And I put all of my step files in a common area because I don't really use them. I just want to import them and convert them. We'll talk about should you use them or not. I'm going to talk about just importing them. So the first one is this filter. Now, when I open this up, it's not going to open up right away. I'm going to get a dialog box that's going to require, just shut that off. It's going to require some input from me as far as what do I do with this step file? How do I convert it? And what am I looking at doing? The first one is your import type. Is it a reference or a convert? The difference between those, if I use reference model, it's just going to open up the step file and I can look at it as is. And I can use it, I can place it in an assembly, but it's going to stay a step file. It's not going to convert it. The most common technique, the one I recommend, is if it's something that you're going to modify and you're going to use it day in and day out, it's going to be more like a library component. Like this one's going to be a filter. I'm going to convert it. Now, I'm only really interested in solids. So I'll shut off the surfaces and anything other than just solids. That's really all I'm interested in. An IGES file, a little bit different. So I'm going to bring this in. Over here is the output location. This is basically, where's it going to go? So when I save this file, when I convert it, it's going to be placed somewhere. And right now it's going to this particular folder called enclosure. It's not appropriate for this. This is a filter. So I'm going to just search my drive. And I am going to put this under my local workspace. I'm not going to put it on documents or a network share. It's going to go in my workspace. All right, so here's mine, designs, comment. I'm going to put it in my, I created a filter folder already. If you didn't do that, you can simply just make new folders and create it when you need it. There it is there.
Jim, sorry to interrupt you. We cannot see the selection dialog box. It's not sharing. That's what they are asking in the QA.
Oh, okay. Let me stop my sharing. I could have sworn I shared the screen and not the application. Let me try that again. Oh, entire screen. Okay. There we go.
Perfect. Yeah, now we can see it. Thank you.
All right. Sorry about that. I thought I shared the entire screen. I did what a lot of times my users do is they share the application. So now we're sharing everything. So here's the input dialog box. Again, reference, convert. I'm going to convert right now. I'm choosing solids. And this output location is where everyone makes a mistake. So I chose filter, but I could always relocate this. You have three choices. I can do source path. So basically save it where it came from. Okay, you can do that. User path. I can locate this wherever I want to. And workspace. That's going to go right to your home, workspace and designs. And that's not really where I want to put this. The most common that I would recommend is user path, and then navigate and pick a folder. Again, it must be in your local workspace because I'm going to use this inside of my assemblies. So I'm going to go under designs. And we'll talk about libraries in a minute, but I'm going to put it in a common folder. This is not a library. And the reason why I'm not doing that, if I put it in a library, as you should be well aware, if not, we'll talk about that. is that the files become read-only immediately because my project file specifies anything in the library path is read-only. That's the only thing that does that. So I'm going to go to Common and Filter. And as I said before, if a folder that you want isn't there, just make new folder and go with that. And I'm going to give the file a name. This is a water filter. It's from the company Dolphin. It's a 10-inch crystal glass globe. So I'm just going to do filter. I'll do Dolphin _10, and I'll just put an MTC because I've already done this earlier, so I'm going to do another one. So that's going to be the file that I create. That's where it's going to be placed, and I just hit OK. Not too bad. Filter comes right in, but we have a slight problem. This is what most people will face, is that this is not just a single file, but if I want this as a model when I purchase it, I'm purchasing the entire body, right? The bracket, the cover, the glass, everything is a component. I really only need this as a part file because now if I use Vault, I got to check all of this in. I have 68 occurrences and I've got 11 unique components. So when I go to check this into Vault, I have a lot of files that I'm creating, saving, and then checking in. Now, if I download another file similar to this, make a different size, most likely the file names are going to be the same. Now I have to start renaming. I just want a single part file and make my life a lot easier. So to do that, we got a couple of choices. I could save this file, right? So I'll save it. I know where it is because I specified that when I imported it. I'll close it. And then when I create a new file, part file, I can derive this part file from the assembly. So I will go to Common, Filter, and here's my assembly. And all I want is a single component. This is what this is. Maintain each solid as a solid body. So it's going to give me one part file with a bunch of solid bodies. I kind of like this because if I want to change anything, if I want to move something or delete something, it's easier than having a bunch of features. So I like the solid body option. I'm bringing in everything I could exclude. If I don't want the sight glass, I can actually just exclude it, right? Right, do that. You can just do solid bodies or primitives, which is kind of silly. I want this to look as accurate as it does, single part file, and I just hit OK. So now this is a single part file. I'm going to give it a name. Same thing, filter, and I'll just call this D10. Now let's go to check this in and let's see what happens. So I'll check this in. Come on. There we go. Wait a minute. I have the D10, but I still have all of the other files that were part of the assembly file. This is a step that a lot of people miss. I no longer need that assembly file that I imported. So what I'm going to do is break the link, not suppress. I'm breaking it. I don't need the assembly any longer. Now it's a static part file that's made up of 11 solid bodies. Now when I check this in, I'll save it. One part file, and that's it. Now I can use it moving forward. I can use it just as a part file. I put in the description, the part number. It'll now behave properly, and I only need a single file. So this was one way of doing it, is you create a new file and you derive this file from the assembly file and then break the link. I'm going to close this, and I'm going to reopen up the assembly file once more. Here it is here. So when I'm in an assembly file, I don't have to create a new part file. and then derive it from here, derive it from the assembly file. I can do everything right from the assembly file just by using simplify. Simplify is not a new command. It's been around for a while, and Autodesk has really improved it. And I'm going to use it in one way, and then in my next example, I'm going to show you some other features and functionality within it. Now, you might say you don't want the bracket. You don't want the screws because you might have another way of mounting this, or you might not use the bracket. You might just put it in line with some plumbing and you don't actually need this, or you might have your own. So you get a lot of choices here. And so that's what this is. This simplify menu allows you to do so much. And there's so many ways of doing that. We could spend a session just on the simplify command, but I want to show it to you in a couple of exercises. So the first one is I can exclude components. I have a couple of choices. I can exclude by size, so I can give a volume. Anything that's smaller than that, it'll just be removed. And it's a great way of sharing a part or an assembly with someone else, and you want to try to protect your intellectual property, so you can hide a lot of things, remove a lot of internal components, and just give the envelope. So I'm going to remove my components. So I'm going to get rid of the bracket and the 4 screws. That's it. That's all I want in here. Now, removing features, this is great if you wanted to remove holes and pockets and things like that. It would fill those voids. And again, that's why they call it simplify. You're simplifying the model to make it lightweight, and it's great for use in. This is what we would do. We're getting a model ready for Revit or in the AEC or the BIM side of it. We're going to eliminate a lot of the internals, fill voids. It just behaves a lot better outside of Inventor. So that's all I'm getting rid of. I'm creating a new part file. I'm using this template file. This is the name that I'm creating. So I'm just going to get rid of the simplify. Don't need that. And I'm going to get rid of the MTC. And I got filtered redundant there. And I'm just going to do clear. This is where the file's getting saved. And same thing. I'm going to maintain each solid as a solid body. And I just hit OK. So it's going to create the part file and then open it. And same thing. I don't need to be linked to the assembly anymore. I'm going to break it. OK. Now I have a simplified part file. Gave it my name, and I can put it anywhere I want. Now, the other advantage of doing this with the solids, I'm going to close this one. I'm not going to use this one anymore. Hide this. And let's go back to the file that I first derived. Let's open up this one here. So here's the filter. I have my bracket, but what I would like to do is maybe extend this a little bit further. So I don't have any features. The only thing I have is solid bodies, but using the direct edit, I have the ability to move faces. So I'm just going to put a window around these faces right there, and I'm going to move it 1 inch. So I've just made the bracket bigger. Now, I am going to use this in conjunction with tube and piping. I'll put some butchens in there. I'm going to run some pipe. I'm actually going to use it in my design. So before I do that, in my manage ribbon, if you guys have not done this before, let me know. I'm going to author this for tube and pipe so it knows how to behave with fittings. I'm going to list this as other. And I got 2 connections on the left and the right side. And it's a 1 inch NPT, and it's threaded. So first thing I'm going to do is locate it over here. That's my center. And then I'm going to locate it again for my direction. The pipe's coming in. This is pointing to the direction that the pipe's going to come in from. And the yellow is the engagement, is how much it can actually insert into this thread. That's on one side. I'll repeat it on the other. Has anyone done any authoring before with tube and pipe? There we go. So this is good, hit OK, and that's been authored. Now what you could do is you can now take this part and you can publish it into Content Center. You don't have to do that. I think it's a good decision to do. I recommend putting everything in the Content Center. I like having a central repository for everything. But again, if you need to make changes to it, you have to make other decisions based on that. All right, so let's close this. So here's the assembly file with the filter that I brought in just a little while ago. And what I want to do is I want to run piping from this bushing to the filter and then from here over to here. So I'm going to activate my tube and pipe. And I'm going to create a new route. And I'm going to route from this bushing to my filter. It takes a few seconds. We all get impatient, but it's a lot faster than doing it manually. So this is giving me an option. If you have never used tube and pipe before, I can navigate through other choices. So that's creating 5 segments. You might have to go around something. In this particular case, I have 2 choices, a 3 segment and a 5 segment. This is fine. And I can also do it manually. I could bring it anywhere I want, but the automatic works fine for this example. And then I'll finish it from here to there. That looks good. I did forget one thing, operator error. I forgot to put bushings in there. So I could simply just delete these segments and add the bushings. And I had just updated my system, so I can't believe I just did that. But again, we all make mistakes. And I'm not going to redo it. I'm just going to show you if I place the fitting. So place fitting is going to bring it from Content Center. Place fitting is going to bring your own fitting in there. You might have downloaded another step file, did not publish it, but it works. So I'm going to do a place fitting. Oh, I had that reversed. That's content, place. So it's a 1/2-inch pipe. It's a 1-inch NPT. So I want a bushing that'll accommodate that. So it's a 1-inch by 1/2 inch. And what's nice about this, I can simply connect. I got to get that pipe out of there. So it's actually pretty simple. All we've got to do is get into the route. I'll just delete that one segment. Just want you to see how the fittings automatically connect if you've never seen it before. Because the pipe was in there, that connection was already used, so that's why it wouldn't go. Now I'm actually able to place it. So I should have put the bushings in first before I ran the pipe. Thank you for not being or being very kind and not letting me know that up front. Okay. So again, I took a step file. I converted it into an Inventor part file, broke the link with the assembly, and all those files can just go away. You can just delete them because the only part I need is the filter. Everything else can go away. Any questions on any of that so far?
No yet.
Not yet. Okay. So the next one I want to show using the step file this is an enclosure, an electrical enclosure that's going to go on the machine. This one's 36 by 36 by 10. It's like a Hoffman enclosure. And same thing, I'm going to convert it, solids. I'm going to put it in a different folder. And I'm just going to do a prefix of MTC. That's good, that's fine, everything looks good, and hit OK. And same thing, we have a lot of part files, we have assembly files, there's a lot, but I just might want this enclosure just by itself, and I can do the same thing. I'm just going to simplify. It's going to create a part file, and I'll get rid of this. Enclosure. I don't need the prefix on this one. So this is good. It's going to go to that folder, and everything is nice. So it's going to create a single part file. I'll break the link. And it's just a single part file that's made up of this one, in this particular case, 26 solid bodies. Now, if you want to hide anything, I can actually change Inventor to select by body. So that's my cover, and I can hide it, right? My visibility. So I can actually see everything. Now, I do have hinges and pins. The way that I created this one, I really can't open it because I created it as a single part file, multi-solid bodies. So this is one way of doing it. Another one, let me close this. And this one. This one's a little bit more intricate. Let's open this up. Another step file. This one's bigger. This is a 60 by 30 by 10 inch enclosure. So this one I'm going to do a little bit differently because I want the body, I want the cover, and I want to be able to open it and maybe even create some positional representations for it. So this is going to be MTC, enclosure. This all looks good because again, when I'm done with this assembly and all the components, I'm going to throw away. I only want basically 2 part files. And the reason why in this case I want 2 part files is I have the body and I have the cover. So this one's a bit busier. There's 86 unique components that make up this assembly. Okay, we have the hinges, we have the pins, we've got a lot going on here. And what's nice about this one, the way that it came in, the way that it imported, is this assembly right here happens to be the door. Everything the door. It's got the latches, right? It's got the gasket, everything that I need for the door is right there. So this will work. Actually, it makes my life a lot easier. So what I'm going to do is I'm going to first, I want the body to go out. I'm going to create the body, then I'm going to create the cover, and then I'll put them together. So I'm going to simplify. So the first thing I'm focused on is the body. So I'm going to exclude. Now this is components. This is parts. That's a subassembly, so I want the entire thing to go. I can pick it in the browser, or I can pick it on the display. So the cover is gone. And this is going to make up my enclosure. And this is what I'm looking for. And maybe the pins too. Looks like they only got 2 pins in here. Oh, only 1 pin, a locking pin. So that's going to go with the cover. And this is going to be 60, 36, 10 body. And it's going to go in the enclosure folder. So it creates it, saves it, and then opens it. That's fine. That's what I'm looking for. So let's go back to the assembly. So now what I want is just this. And the pin is in here, right there. So these two assemblies is what I want. You can even rearrange them so they're together. That might make life a lot easier. All right, so I got that assembly and that little assembly, those two. Well, let's just bring them down to the bottom. So let's make the cover. I'm going to simplify. Now I'm going to exclude by component. So I'm going to exclude everything here. So the only thing I see is the cover. I'll get rid of this. And that's fine. This will show all of the occurrences that I'm shutting off. So you can take a look at it. That's what I'm removing. I like to think of this like carpentry. Measure twice, cut once. Take your time with this, because otherwise you're going to make a lot of miscellaneous files you're just not going to need. So this is good. This has everything that I need. I've got the cover, I've got the body, and I hit OK. So here's my cover. I don't need the assembly, so I'm going to break the link. Here's my body. Don't need the assembly. Break the link. So now I have two parts, body and the cover. Now what I'd like to do is to create an assembly file. And I'm going to put this in my enclosure folder. And in here, I'm going to create a folder called Hoffman. So that might have all their manufacturers. And this is a 60 by 30 by 10 body cover. Then all I'm going to do is take the body, I'm going to copy it and paste it. I get my cover and copy and paste it. Now I need to put these together. So this distance is smaller than the opening, so that needs to be centered. So a lot of you might create work planes. I might put a work plane between these two faces and these two, line up the centers. This is where the joint command or the joint constraint comes in really, really handy. It's a lot easier, faster than using constraints. So I'm going to use the joint. Now, I can pick up that, I can pick up that, but I want to get right in between them. You right-click between two faces. I pick this face and that face, and there's my center, right between them. And then I want to pick up in the center between here. That's it. Now, it's defaulting to rigid, which means it can't move after, but I want this to be able to rotate. Now the door can actually spin. So I'll take this, bring it over, and now I can manipulate it. So what I want to do is let's close it. So now I will add a traditional constraint between this face, that face, and I use three options so that the vector is always the same. 0, 90, 180 always goes in the same direction. And I'm going to pick up a edge. And it really doesn't matter what edge, it's just really direction. You'll see the arrow, if I zoom in, how it points that way. That's what I want. So right now that's 0. If I put in 90, it looks like that. If I put in 180, it looks like that. It's closed. So 180 is closed, 90 is halfway open. So at any point in time, I can make that 90. I can make it 0. back to 180. Under representations and position, I'm going to create a new position. And I'll make this open. And now what I'm going to do is for this position, I'm going to override the constraint. It's enabled, and it's going to be 90. So now I have, let me update it. There's my primary. There's my open. I save this. You can't save it while I have it in a position. It's going to switch me back to primary. So it's saved. But now this enclosure, I have the body, the cover, all the mechanisms that make up the cover. And I have that. If I go to check this in, 3 components. I have the assembly file and the body and the cover. That's it. Completely simplified. I can use this in any designs that I need. If it's involved, I can now copy design it because each enclosure might be slightly different. I might have cutouts for panels and displays, things like that. So now I have something that's really simple to use, simple to work with, and I can modify it per machine as I'm working. Hey, Patrick, how are you? I just saw your name pop up. I can't see all of the names. I can only see a few on the top, but thanks for joining. Any questions on this workflow?
We don't have anything on the QA.
All right. Did anyone see anything new? This is why we're trying to go back to live. I really prefer to sit in front of you and to really kick the tires on the software and have you guys test me to make sure, see if I can break it, see if I can trip and fall. Anything, any questions, any comments? I'll put my camera back on. So what we're trying to do is make these presentations appropriate for you. So if you have any presentations you would like to see, please reach out to your sales rep or reach out to Anna and then put the request in. And I look at those and I will work with that as far as developing a presentation on this. Today's presentation was only because since January, I've gotten a lot of requests working with step files, a lot of support. So I thought it would be appropriate and useful for today's session. So I really would like to hear from you today, or even moving forward, anything you would like to see for presentations. Does anyone have any questions or comments outside of the presentation? This is a user group. I do a presentation to show something, so to give you guys something to look at when you're here, but this is not what the user group is about. We want to help you to be better with Inventor, Vault, electrical, anything that you're working with. You know, this is an open forum, so feel free, reach out, let me know what's going on, and we can answer the questions as they come up.
Okay, Jim, I think we have here, so it says, should a step file be converted into Inventor files or use it as it is?
All right, so great question. So if it's a step file, so here's an assembly. Let's say I want to bring that filter in here. So if I place a step file directly, here's the filter. This is the one I downloaded. And I'm just going to place this. I'm going to use the reference option, right? I'm not going to convert it. So here it is here. So this is a step file, and it looks differently in the browser. Let's see if I can actually zoom it. There's a little application I found. If anyone's interested, I can actually zoom in on my screen. Oops. I'm not an expert with this, but you can see this icon for the filter looks different from the Inventor part files because it's a step file. Now, here it is here, and if I go to check this in, it will check in. It'll work just like any other file. So the advantages are, if I'm designing around this particular step file, let's say I just saw Brian Jarrett on there. So let's say Brian sends me a step file and I'm going to design around that. Maybe it's my truck body, Brian, right? So I gave you my truck body as a step file. You're going to design your structure to fit in it. I go through an iteration. I make it a little wider and a little longer. So if I send you another step file, you would have to re-import it if you used it and you converted it. If you use a step file and your intention is to work around it, not really to modify it, if I send you another step file, you can simply overwrite the step file that I first gave you, and it would update it, and the assembly would update, and everything would work nice. So there are some advantages. However, what I found is that if you're not going to work in that respect, I'm going to download a model. I'm never going to get another one. I would convert it because Inventor files just work better. They're more consistent. I've had issues with extraneous geometry because what we don't know is like who created some of these models to create the step files. I've seen corruption happen with some of the part files. I would definitely recommend converting it. But in the case where I might get step files over and over again, different revisions, I might use it as a native step file and then just overwrite it if I receive a new one. But you can do both.
Awesome. And here we have another question. It says, can a step file be added to the Content Center libraries?
A step file cannot be, but once I convert this, and let's see, common. Let's do part file. I'll just open this guy up. So if I convert it and it's a simple part file, then I can actually publish it to the Content Center. And again, I would recommend that, especially something like this. This will be incorporated into the tube and piping. This will work out really well for going into the Content Center. Again, it's central location. My bushings, my reducers, my T's, elbows, everything's in Content Center. I would put everything together. So to me, I would publish this into Content Center. And it just, again, it's a central repository for common components. Okay.
Awesome. And here we also have another question. It says, if I use a step file in an assembly, how do I update it if I receive a new version?
Yeah, so I had just answered that with the previous question, is that if I have the step file in the assembly and you receive a new one, you simply close the file, overwrite the step file, and then reopen the assembly, and it will update it dynamically inside of the assembly. And anything that might have been created from it, projected edges, all work. They all stick. They're all static. They work fine.
Perfect, Jim. Thank you so much for that presentation. I just see here in the QA, okay, Patrick and Brian saying that they did learn a couple of things that they were not aware of. So that's great. And also Patrick said the step export 203 versus 214 versus 242 versus others.
Yeah, Pat, okay. I don't have any information on that. I'm going to take the question. Anna's going to send that to me. I'm going to do a little research on it. Autodesk they're always updating. Like whenever you go from 2024 to, let's say, .1, .2, .3, and then 2025, and then the dot updates, most of the time, I can bring this up over here. You'll see it when I go to help. And this is something I always recommend. When you go from one version of Inventor to another, it's really useful to go through the what's new. This is what's new in 2025. But you'll notice that I've got, this is when 25 first came out, then it was a .1, a .2, and a .3. And translators, right? They're typically always updating the translators. So let's see here, 2025 translators. Not a lot here, read-only mode, but I'll go through this, Pat, and find out what's changed between those different versions. I lost the meeting. There we go. But I'll see what I can find out for you on that.
All right, and we have one from Paul. He's asking, how do you convert surface step files to solid?
A lot of coffee, a lot of patience. They'll keep you up late at night. It depends on the surface. Typically, it's an IGES file. I don't know if I have an example. Let's see if I can find one quickly. Let's see, customers. All right, SPF, let's try that one. So if I open, where's my just right there. So I will say, let me see the subfolder. Nope, nothing in there. If you receive an IGES from someone, the first thing I would do is reach out to them and ask them for a step file. That's a lot better. If you do get an IGES file, I have no idea what's going to open up here, but we'll see. Some of them convert pretty simple and some of them don't. Because it's an IGES, sometimes an IGES file can include solids, but they usually don't. So I'm going to include both. And I'm just going to take the defaults. Actually, I'm going to do source. And let's see what opens up here. Yeah, this one's not going to convert very nicely at all. So what happens is this is just way too busy. In order to convert this into a solid, it has to be watertight, which means it can't be any gaps or holes. And I got a bunch. Let me see if I can. Let's see if I can take this one here. Let's try to narrow it down a little bit. There we go. This might work. So this is a part file. It's a composite. In order to convert this into a solid body, because if you've ever worked with surfaces, they're not nice. They don't look good. They're translucent. You got to make them opaque to try to see them. They just don't behave well. So this is the typical workflow is, and by default, this is not enabled. So in application options, in part, you have to enable the construction environment. By default, I don't know why that's disabled. You have to turn that on. What that allows you to do, it takes this composite and I copy it to the construction environment. Then I will hide this because I don't want to see it. And then in the construction, I will edit. Now I have 115 surfaces. So fingers crossed, let's see what happens. First thing I do is I do a quality check of my surfaces, right? Selects all the surfaces and examine. Pretty good. Then if everything works, I can stitch them together. And it creates a solid body. Now the solid body is still in the construction environment. So then what I do is I copy the object as a solid up one level into my main environment. There it is. Now I can delete this. I can delete the construction. And there's my solid body. Some of them work good and clean. Some of them, was not a good example. If there was a hole in here, I'd have to use other commands like patch. I'd have to fill the voids. Again, it has to form a watertight boundary. Those usually convert pretty nicely into solids. If they don't, you have to clean them. Sometimes you might be missing a face or a cylindrical wall, and it'll show that to you and try to stitch it where it's failing. And then you have to go through and use surfacing commands to stitch everything together. You'd have to create a boundary patch over here. another boundary patch between these two circular edges to create the cylinder wall inside the hole. Once you have that, then you can stitch them together and it creates a solid, but it can take a lot of time. That's why I recommend contact the person, the entity, whatever, where you got these IGES file from, so you can get a solid step file. It'll just make your life a lot easier. This is clumsy, and this is one of the things we can work with you. So we have different support options. We have the manufacturer productivity suite, which includes some support, and we can, with that support mechanism, we can help you with a little bit of workflow as far as holding your hand, walking through, if you got a particular example, how to make it a solid body. And this is what we do with our support. So if you have anything, I'd be glad to, myself or my colleague JD can work with you on converting these files to solids. And the other advantage is solids, they have mass, they have moments, so you can use those in all of your analysis.